Hi, I'm David Altamir. I want to show you how an ERP-generated production schedule can be used to drive pull-based lean flow on the manufacturing shop floor using a production scheduling and control paradigm that I call Lean MRP. Lean MRP isn't software. It's a management approach. So that means that Lean MRP can usually be accomplished using your existing ERP system without requiring any additional capital investment. The benefits of managing your operation of Lean MRP are reduced schedule volatility. And with reduced schedule volatility, you'll have a set of shop floor priorities that are more directly connected to the customer requirements. Then you'll be in a position to attain better on-time performance. You'll also be able to enjoy all of the benefits of lean manufacturing, including lower WIP inventory, and with that comes shorter manufacturing lead times. All of these things together will put you in a position where you can make reliable promises to the customer. I'm sure you'll recognize all of these things as having a favorable bottom line financial impact. Now, when I talk about a production schedule driving lean flow, many of you will try to reconcile how a production schedule, which is something that's normally associated with the push paradigm, can be used in the context of lean manufacturing, which is something that's usually associated with the pull paradigm. So to resolve this apparent contradiction, we'll be treating manufacturing work centers as Kanbans, which will be providing pull signals to upstream work centers whenever capacity is available and demand exists. We'll also be doing it in a way that can support a very large diversity of part numbers flowing through common resources, and it'll be scalable no matter how large your operation is. You can think of Lean MRP as a traffic control system that limits congestion and reduces travel times for materials and products moving within the factory. Lean MRP therefore lends itself very well to job environments in contract manufacturing, aerospace, medical devices, and other similar industries. So I'll be introducing the Lean MRP concept in two parts. First, we'll show how to manage a production schedule that's stable, extremely customer-driven, and is useful for driving shop floor priorities. We'll call this the baseline production schedule. Then secondly, we'll look at the mechanics of managing material flow using lean pull signals that are delivered to every work center using an electronic web-based lean dispatch list. So these two things together, the baseline schedule and the lean dispatch list, constitute the Lean MRP production control system. Traditional ERP-based production scheduling looks like this. We have a planning function that receives customer orders. Those customer orders are translated into a production schedule that's then delivered to the shop floor. That production schedule is basically expressing when jobs are needed. It's a set of due dates. The shop floor acts on it, and the shop floor is an oscillator. It's volatile by nature because it's a physical operation. So it is then going to feed back to the planning function an idea of how the production process is faring, and it usually comes in the form of ECDs, estimated completion dates, that express when will jobs be finished. So these two questions, when is something needed and when will something be finished, are the two types of business questions that we usually find. And in traditional systems, it's all answered using one monolithic schedule. The problem is that those two types of questions cannot be answered with one set of scheduling assumptions. Those scheduling assumptions that the ERP system needs to use to generate those results involve two separate, internally inconsistent set of scheduling assumptions. So what you end up with is you have a shop floor that's already volatile by nature, and then you have a feedback loop that's inadvertently set up that now infects the planning function, and it too, your schedule, becomes volatile. So that's not a control system at all. That's really a recipe for chaos. And note that the use of frozen fences or schedules that are printed out weekly instead of daily don't really solve the schedule volatility problem. They only mask it. So with this traditional approach, one gets the sensation of running as fast as you can but getting nowhere. Lean MRP, in contrast, requires the use of two separate production schedules to establish a stable, customer-directed control system that's more effective. So in this example, we have the planning function receiving the customer orders. They are translated into a baseline production schedule that's delivered to the shop floor. That baseline schedule only changes with customer demand. It expresses demand and basically is telling the shop floor when are things needed so that priorities can be set accordingly. The shop floor is still volatile by nature, but it should be less so because now it's not receiving a fluctuating set of commands from the planning function. Then our feedback loop is now separate and it's informational. It is expressing in the projected schedule when will jobs be finished. So we've separated it out and now we have a control system and that feedback loop is controlled and the volatility of the planning function should be much less, in fact something close to zero, only that on the order of the volatility of your customer demand, and unless they're changing their minds all the time, it ought to be pretty placid. So the objective is to end up with a set of baseline and projected schedule dates for every production operation in the factory. It's only then that we can have a way of knowing whether each area of the factory is early, late, or on time for every part number at every level of the bill of materials. Now, when the projected schedule deviates from the baseline schedule, we then have an early warning system in place that can help manage the shop floor to control outcomes before it's too late. The end result is improved on-time performance and a newfound ability to keep customer commitments. This approach to scheduling is commonly used for project management, but ERP production scheduling systems aren't typically set up to do this out of the box. So some effort may be required to implement these concepts in your system effectively. With a baseline schedule in place that's stable and customer directed, we now have a reliable way of prioritizing work through each work center. Optimally determining the job that should be worked next is one of the most powerful tools we have to enable on-time performance. The improvement can be dramatic when applying the concepts of Lean MRP. So the baseline schedule that I've just described lays the foundation for what's next. The Lean dispatch list, which is the key to enabling lean pull-based material flow. Before we get into the details of the Lean dispatch list, let's contrast it with the traditional ERP push-based approach. So in this example, we have 3 work centers in series. We have raw materials entering on the left, products that are completed exiting on the right, and we have inbound queues in front of each work center. So this is, the inbound queues are typically, if you were walking in a factory, that's where WIP inventory would be piling up. And those are the things that increase your lead times. To make matters worse, we're setting the priority of work that is sitting in the inbound queues and prioritizing it using a production schedule that, as we just discussed, is very volatile because of this feedback loop effects. You're, in essence, attaching an oscillator to every work center in the production pipeline. So that's the traditional approach. With Lean MRP, we have an approach that's significantly different in the way that material moves through the factory due to the fact that we're controlling the output of the work center using an outbound queue. So in this example, we have the same 3 work centers, materials moving from left to right, but we've moved the queue to the back side of each work center, and we are using the baseline schedule to drive a lean dispatch list that's providing each work center with signals as to when it's appropriate to move product forward in the pipeline. So let's drill into the outbound queue and see how it works by looking at a single work center. So in this example, we have a work center that has a work area that has a capacity defined in your ERP system. So in this example, we're illustrating that the work area has a capacity to accept 9 units. Then we look at what the capacity is for the work center as a whole. That includes the area where work is being done, but it also includes the outbound queue. In this example, the whole work center can accommodate no more than 12 units. Now let's look at 2 of these work centers in series. Let's say that the 2 units are completed in the first work center. Now these can be immediately moved to work center 2 because work center 2 has capacity available to absorb it. However, if we look at a different situation, this time with 3 work centers, And let's suppose that we have a bottleneck at the third work center. Its work area is completely full, and so it can't accept any more units. The Lean dispatch list communicates this upstream to the second work center. It's essentially saying, don't bother sending any work to work center 3 because they're full and unable to accept new work. In fact, the bottleneck has become so egregious that the second work center is completely idle, with its full load of units lying exclusively in the outbound queue. So that means that the first work center, in turn, is also constrained to hold its work because the Lean dispatch list is providing Lien signals to it as well. So hopefully you can get an appreciation of how we've established a control system where material flows in one direction and Lien pull signals are being transmitted upstream using the dispatch list to mediate Lien flow. Now, we've only been looking at simple linear examples so far because this is a brief introduction, but understand that Lien material flow can be established using Lien dispatch lists in a multidimensional network with a large number of part numbers, work centers, and routings, no matter what the size of the operation. So now would be a good time to show you what a dispatch list looks like. This is usually delivered to the shop floor as a web page that can be customized for each work center. The top part is the kind of dispatch list you'd normally find in any MES system or that you'd be able to obtain as a static report from ERP. And it's listing all of the jobs that are currently active in schedule priority. If you're lucky, it'll tell you whether each job is running or idle, and it's giving you a sense of priorities. Now remember, this is connected to the baseline schedule, so these priorities are going to be much more connected to the customer requirements than they would in a traditional system. Now the bottom part is what's special. That's where the Lien signals come through. In this example, you can see that this job is free to move is free to move forward to the next work center, but you're getting 2 hold signals for 2 other jobs that are being held back, presumably because there's a bottleneck downstream. Now this is something that can be quickly developed as a real-time web page with a read-only connection to an existing ERP database. So that's our brief introduction to the Lean MRP production scheduling and control methodology. I think it's a novel method for using ERP to support Lean pull-based flow on the shop floor. Feel free to contact us by email or phone to discuss your needs and see if this is right for you. I hope that Lean MRP can offer you with a transformational opportunity to improve the performance of your manufacturing organization. Thanks.